Welcome to the episode 1 of solving ROS2 community problems. In this first episode, we are going to be solving 5 problems, and the sources are Stack Overflow, Robot Stack Exchange, and ROS answers. From the next episode, I will also include my Robotism Discord server questions as well. So these are the 5 questions, mostly beginner level. They are not very complex. Basic ROS structure, data manipulation of the sensors, namespaces and transforms are the concept that we require. Let's start with the first question. Follow wall and avoid obstacles using LiDAR, and it is asked 25 days ago. Nice. So I want to follow a wall and avoid obstacles on the way. So it requires 2 robotic behavior: follow wall and avoid obstacle. A snippet of code is provided. Let me just copy it to visualize properly on my VS Code. Okay, now I understand. This is the robot. It requires to move, and as there is a beacon upon it, let me zoom it, and as there is a beacon upon it, this guy needs the robot to be following, but when the obstacle comes, it should move to the right and then get back to the track and something like this. Okay, I tried a lot of different solutions, but I did not receive any goal. I checked this article, heading follow, and but it really okay. So basically, this guy is saying that I didn't understand how that happens. My robot sometimes stuck between an obstacle, turning on both sides. I think the PID can't help here. PID is just a control algorithm, not solving the obstacle avoiding thing. Here is the code. Okay, he has provided the code. Let's try if the code is correct or not. Let's paste it. Subscribing to command velocity, subscribing to the laser data, not providing any information about how many scans the robot LiDAR sensor is providing. The first point. The second point is in the callback function, whenever the laser scan is obtained, setting everything to 0, although if you just initialize it, everything is already 0. Then it says let, I don't know what this let is. You should be using some appropriate variable name so anyone who is reading your code can understand. 4.0, fine. Left and front. From this sensor range, you get the left values. From this sensor, you get the right values. Basically what it is, if the obstacle is there on the left, we can find it. Then the condition is if left is less than let and front is less than let. We have to understand it with the condition applied in Github. Let's bring it on the side. If the square is my robot and there is a wall on this side, let me stretch it, and I say that on the left and front the value is less than 4 and there is an obstacle as well. So this sort of scenario is produced in the first if. Then it says angular z velocity with this has to be applied. Until this condition, you are going to be trying to, as it is negative turning of speed, so it is going to turn clockwise. So it is going to turn like this. Okay, fine. Now the robot is on this angle, and as soon as the robot turns like this, the front is less than let gets cancelled and your robot is going to stop turning. Fine. What to do after this? If left is greater than let at this specific time, that's not happening. Okay, then forward speed is going to be applied. Then the robot is going to like this. If left is less than let, meaning now the distance is less than 4 and front is greater than. At this specific point, you are going to turn your robot back. Fine. And this is going to be slower, dividing by 2. Fine. At this specific point, left is less than let because the obstacle is right on the left, and front is not less than less. So forward speed is going to be applied. So our robot is going to be moving forward. This condition gets false and else is going to run. Fine. At this specific point, left is greater than let, front is less. So you are going to turn and you are going to somehow get here. And you're just publishing it, and there is no obstacle avoiding code here. Your wall following code is working fine to some extent. But if you have provided the code, I would run the simulation and find it out. So the problem is you are requesting for the actual code. We can only provide an algorithm how you can integrate with it. And I think you should be using some cases or sort of state machine so the robot can understand, okay, I'm at this specific condition. Now, when I fall into obstacle avoiding, from which side I have to avoid the obstacle and something like that. So this is going to be a lot of code here, not just these simple conditions. I have provided some answer to this guy, and the answer is quite simple, that you are just performing wall following, not the obstacle wording with it. And PID is just for smoothing thing. You can look at for bug2 algorithm, because bug2 algorithm says like if there is an obstacle, directly go towards it, and then it starts to follow the boundary of it. So somehow it is going to be doing wall following and obstacle avoiding until unless the obstacles are placed closer to the walls. But if you want something dynamic like this, obviously you have to then switch between going for bug 2 or wall following. Next issue is related to ROS2. Launch file does not spawn my custom URDF. His custom robot is not being spawned. Any other information? No. Interesting. Let's take a look on his code. Okay, warmbot URDF file is provided and Gazebo is launching. So when you are bringing a custom URDF, you need to bring in Gazebo, obviously, provide a URDF proper path, and you have to use Gazebo spawn entity to bring the URDF or an STF into Gazebo simulation. There are some arguments that you can provide for XYZ rotation and yaw. Then you bring in all into the launch description and everything should be working fine. As we don't have the URDF for this guy, let me bring in one of my package, which is of my course, ROS2 Ultimate Mobile Robotics course. And we have rover package. Let's go into Gazebo spawn launch file that brings the robot into the simulation. Let's run this launch file and understand if it is working. Then we will fix the problem with this launch file. So robotism ROS2 launch, name of the package is rover, to Gazebo spawn launch. This robot is spawned perfectly. We can move it as well. Yes, it is working fine. So spawning is done properly. Let me close it. Now what I think I should be doing, I should utilize this code and spawn the robot again because I have the URDF file. Let's look at the main things. Gazebo execute process, same thing is happening. The node to spawn the robot, Gazebo spawn entity, and name is not provided, no problem. Output screen entity, the robot's name, its file is URDF file. In my case, I'm using on the robot description topic, and XYZ arguments are provided. I think we can get these arguments with the help of -h parameter, ROS2 run Gazebo ROS spawn entity -h. It provides all of the available options we have for bringing in the robot. The guy Mubashir is using file as URDF file. So file name, load entity in XML from the file. Fine, I'm using the topic that also utilizes XML published on topic. So the main difference is I am loading my URDF file into this variable which is given as an argument to robot state publisher, and that's it. Let's try to follow this procedure and try to give the spawning file as an argument to URDF, which is going to bring in my robot. And let's get rid of robot state publisher, although robot join publisher is still required. And let's get rid of these robot description and the topic. This file is this, entity name is rover. Let's perform call can build and run the launch file again. Similarly, you can see the same procedure happened. The robot is there, we can move it, we can drive it. There might be some topics available as well. If I say ROS2 topic list, I have closed the Gazebo, that's why. But it is working fine as differential drive plugin was also loaded. So this way is fine. I think the problem is with the URDF that you are trying to spawn. That might be the problem because the same spawning node written here is also working. For now, I'll just write this and after the video provide the link of the video and the repository as well. The third problem is little problem with webcam publishing in ROS2. I am publishing image but it is not real time. So meaning the ROS pipeline is fine, only the problem is with the speed. As it is saying publishing image like delayed images. I try to fix it but I can make it. So you don't need to search for ROS pipeline because it's already there. You have to just see the timers or your approach in publishing and subscribing. So this is the publishing code. Let's get the subscribing code. Let me make all of these smaller so I can easily see. Some libraries, let's get rid of them. It is publishing on topic. This is subscribing on some topic, deleting all of the unnecessary things. It is publishing on 10 milliseconds, defining by himself, and it is subscribing on the topic whenever it is available. Then He's converting it into BGR and then IM show. Fine. There can be many things. If you can't see in real time, the problem might not be the ROS, but CV. The way it shows on IM show is going to require some threads to put on. If it is running on one single thread, that might be the problem. And one very common mistake that a lot of people make is this thing. You are initializing a video capture object again and again inside of a caller function with a 10 meter per second speed. That's a problem. You have to define it once inside of your publisher, and inside of the callback function it should be calling it again and again. And if you want to keep it private, you can bring it here where these other private members are defined, which will publish it more probably. Let's try to fix your code and visualize what you are publishing. First, we need to create a C++ package, ROS2 package create. The name of the package is test CPP because all of the CPP files will be here. I am in the workspace source directory, not going to provide directly the name. Package create, the build type is going to be aim and cmake, and press enter. And so we have test CPP, cmake list and trusting. Let's create webcam.cpp. Let's bring in the publisher code, visualize with RVIZ. Let's save it. A lot of things are being included. We have to tell the cmake list about it. So this is the dummy pipeline for producing an executable. It is going to be webcam test. It is going to be in source directory. Name of the file is webcam.cpp. What are the dependencies? This is an important question. We have to bring the file side by side. First, let's tell this is the executable you are going to be linking everything with. So it is using CV bridge. We need CV bridge. It is using sensor message. We have to tell sensor message, standard message, and obviously RCL CPP, otherwise nothing is going to work. And OpenCV, this is going to be included with this target link libraries, and we have to tell the executable as well. Now once we have added all of these required libraries for the linking process, we have to tell where to find them as well. Now to build it, you have to go into your workspace and now perform call can build. Otherwise things can go very messy. We missed one library, that is image transport, similar to find package. Bring the image transport and you are going to also add it here. And once all of the dependencies are done, you also tell to install the targets, where you tell the names of the executable and put it under the project name. Let's perform call can build. So it has successfully built with some warnings, but our package is perfectly built. ROS2 run. Name of the package was test CPP. It is not finding. I will source my workspace. ROS2 run test CPP. It is finding it. Webcam test. Webcam is turned on. Let's press enter and it is working. So RVIZ2 to visually see what is happening. Add image and now you are going to see me topic, and here I am, quite low light. It is very slow and stucking. If I put some light with it, still it is stucking. It is quite slow. Let me stop it and let's go into the code. Let's make the change. Let's fix this error by bringing it into our class declaration place and say that cap is equal to this. We are going to get rid of this approach. Now it says it is not defined, right? So we have to define it as a variable of the class. We'll also define it here as CV, video, capture, and cap. Everything seems to be fine. Let's perform call can build and we have to compare it with the previous result as well. Now let's run this and whoa, the speed has increased too much. Let me reset it. It is saying no image. Remove it, add the topic image again, topic. Now it is not showing in RVIZ, but we can see the difference. So let's test it with the publisher now. I will create another file, call it to be subscriber, and make the changes in the CMake list. Add a publisher, and for all of these web tests I have to put the marker. Same libraries are there. I have to put the markers here and say sub. It is sub. Now let's bring in the code that the issue has provided. For the sub, this is the code. Stop it and perform call can build. ROS2 run test CPP. What are the nodes? Webcam test. ROS2 run test CPP webcam test. It is going to start publishing the values. Fine. We just have webcam test. Why don't we have the other webcam test pub as well? We have not added it into install targets. Performing call can build again. Now ROS2 run test CPP and webcam test. There is a sub as well. Let's see. And just wanted to test the no code, although this code is commented out, and with the callback function you can see in 1 second 30, 31, 32 how many frames are being presented. So the problem is solved. So let's move to the next question. The question number 4 is displaying 2 robots in the same RVIZ window. Okay, I want to add a robot using UI. Any help is greatly appreciated, thank you. You then answered it and I said I was able to do it by prefixing all the frames. Oh, nice. Nothing else. So I just wanted to give more insight into it because this is very important for everyone who is working with multiple robots. What prefixing means: adding a variable or a string before the robot. Let's take a look into Turtlebot 3 for example. Let's bring the robot that I already had, rover launch file. We are going to be using RVIZ launch file, ROS2 launch rover package that I have, and one RVIZ.launch call can build it before running it because there are some changes. What we will be doing is adding information for this joint state publisher and robot state publisher with the names. So we can see something is there, and we have changed it to chases, and our robot is there. We can move its wheels and we can see the robot. Now the thing is, regarding the robot model is using robot description. The guy in the question was saying that if I added something as a TF prefix while bringing everything up, it is going to solve it. If we perform ROS2 topic list, we get these values with one robot. Now let's close everything. And we are interested not in this GUI node, just the robot state publisher. Copy it and paste it again. The package is same, executable is same. Let's rename it, but with the same URDF. Bring everything up. And as both of these robots are published without any error, we are going to add another robot model. This time, the issue is we have only one topic, robot description, for both robots. If I uncheck this one and uncheck this one, you can see the robot disappears, meaning that on both robot model, robot description is publishing something. So if I enable this one, robot is there. If I publish this one, robot is there. With the help of ROS2 topic list, there are same things happening. If we perform about scan topic, ROS2 topic info of the scan, a single subscription is there. So let's close it and perform a namespace to it. Namespace is a very important concept for multiple robots. The first namespace is going to be for robot 1, and similarly we'll give another namespace for robot 2. Rerun the launch file after building it. Chases, and now you can see not even the first robot is there because I have added some prefixes. On ROS2 topic list, we have robot 1 joint state description and robot 2. This is known as the TF prefix. So to visualize the robots, we have to tell the robot that this time robot description is not the robot description, it is robot 1 description, and then it is going to appear. Let me disable this one and bring the description topic to be robot to description, then the robot appears. So this is the TF prefix. Everything is now prefixed, but obviously the wheels are not there because the joint state publishing for the wheels is not with the prefix. But in simple words, that's what is happening. Coming to the last question, setup tools depreciated warning. This is a very common one for people who are just starting out in ROS2 and Python packages. Whenever I perform Colcan build, you can see this error comes up. For this rover package, which is Python package, it says that this is the error that comes into, as this rover package was created for ROS2 Foxy, and it is saying that we are facing this error because of this simple problem. And there are two packages for this, Prius as well. We can take a look. Name this instead. It is telling us it's related to the Python modules. Let me fix that, and then we will come to the next problem as well. Now perform Colcan build. Now you can see the error that this guy has shown, setup tools depreciated warning. It is now appearing, and it says that setup.py install is now depreciated. Use build and pip other standard based tool. The problem is with all Python packages, this is happening right now. If there might be some fix, but I have not found any related to that. One way is to shift to C++ if you want, because in C++ this doesn't appear, that is, it is dependent on Python. If I create a package here, for example, ROS2 package create, and its build type is imminent Python, name it to be test.py, then go into the workspace and perform Colcan build, and you can see in finished, it has finished test.py. But for test.py, it has provided this error, although I just created it. So this is something that you don't need to worry about. It's just a warning. It does not interfere with the process of your nodes and anything that is related to development. One very cheap way is to just find out the version that does not give this error. But that might become a problem for you for setup.py file if you have any dependency. What I'm talking about is setup tools import setup and then print out its version. Currently I'm using 67.1. If I degrade it to 58.2, let's say, and I say bring me the 58.2 and uninstall the 67.1, it says that a lot of your libraries are going to collapse because of this, but it has successfully installed it. So if now I perform Colcan build, there will be no error. So I think the way that Python for ROS2 is utilized for the package creation, the way it is using setup.py procedure, that is depreciated, but it is way older than the one we have as an updated version. If you have any issue with the error, you can simply remove it by degrading to this specific version. If not all, you might have learned something. So the main learning outcomes that I can conclude are URDF, sensor data manipulation, launch files, namespaces, which is very essential for beginners to understand how to work with multiple robots. And with these, some of the learning outcomes, we are aiming to help the person who asked the question and you and me and the community who will face later on. So this video will help them.